A randomly selected group of individuals were asked to keep track of the number of days they had watched television. The following frequency distribution summarizes the results. Complete the table by determining the midpoints, relative frequencies, and cumulative frequencies. Let's begin with the midpoints. Now, the midpoint of a class is the middle value of its lower and upper class limit. So looking at this class, its lower class limit is 40 and its upper class limit is 51. The middle value of that class is maybe like 45.5, 46, somewhere in there. So when I come up with my midpoint, I need to have something close to that. You can get a good estimate and check your work against that estimate. Now, the formula for a midpoint, so it says to take the lower class limit plus the upper class limit and divide by 2. You can memorize this as a formula, or you can think of it as a process that you already know. This is, in effect, averaging your class limits. And the way it is doing an average is, even though you don't have 12 data items to work with, an average says to take all the data items you have, add them together, and divide by the number of items. So here I have 2 data items, a lower and an upper value, and I'm dividing by 2. So that is in fact an average. So just think of it as an average, and you don't really need a formula. But to get the midpoint of the first class, let's take the lower class limit plus the upper class limit, and do be careful to make sure you do this operation first and then divide by 2 so that you don't get order of operations error. And we come up with 45.5, which is right in line with what our estimate was. So I think that we are just fine with that value. Next, we want to get the midpoint of the second class. So we would do the same thing. Take the average of 52 and 63. And that gives me 57.5. Okay, now, one thing I want you to notice here is for any frequency distribution, you can get its class width if you take any 2 consecutive upper class or lower class limits or upper class limits and subtract them. So for instance, the class width of this distribution, if I take 52 minus 40, that gives me 12. Likewise, 87 minus 75 is 12. 75 minus 63 is 12. This 12 is a constant value throughout my table. Also, if I take 57.5 minus 45.5, that's also 12. It's no surprise that if all my lower class limits are off by 12 and all my upper class limits are off by 12, that the middle value of those classes would all be off by 12 as well. So I could just simply come up with the first one and then just repeatedly add 12 to get the remaining ones. So 57.5 plus 12 would be 69.5. Plus 12 more would be 81.5. And plus 12 more would give me 93.5. And it's always a good idea to just make sure these line up with what you expect to be the average of those 2 numbers. Double check yourself in the end. The relative frequencies. To come up with relative frequencies, there is a formula. The formula for a relative frequency is the number of data items that exist in a class, so each individual class frequency, divided by the total number of data items altogether. And the relative frequency is really just a percentage of the total items that exist in the table per each class. So what we'll have to do is find out how many data items exist in the class. So the number of data, that exist in the table. So the number of data items that exist in the table is going to be the sum of all these frequencies. So let me use the calculator so I don't make an arithmetic error. But if I take 10 plus 5 plus 8 more plus 11 plus 6, that gives me 40 data items. So my relative frequencies, these are just percentages. So 10 out of 40. So I have a frequency of 10 divided by 40. That gives me the first relative frequency, which should be 25%. Whoops, thinking 25% in my head. 10 divided by 40 is, 25%. And you can write these as percentages or as decimals. Just follow what you're asked in the homework, that's all. The next relative frequency would be 5 over 40 then, which would be 0.125 in this case. And then 8 divided by 40 is 0.2. 11 divided by 40 is 0.275. And finally, 6 divided by 40, that is 0.15. Now, one thing that is interesting of relative frequencies is that for a frequency table, all of your relative frequencies will add up to 1. So it's a great idea to just double check yourself at this point. Make sure these add up to 1. And if they do, you're certain that you've got the right relative frequencies. Then you can move on to the cumulative frequencies. And there isn't a particular formula for cumulative frequencies, but there's more of a process. And the process is to allow each frequency per class to accumulate from the first class all the way to the last one. So for instance, if I take the cumulative frequency of the first class is the same as the class frequency of the first class. So we just start there. So we just take this 10, move it over, that's my first cumulative frequency. Now, my total so far is 10. Now I'm going to add to that the next class frequency. So 10 plus 5 is 15. So that's my next cumulative frequency. So I'm allowing these to accumulate. 15 plus 8 more is going to be 23. Then 23 plus 11 is 34. And 34 plus 6 is 40. And note that the last cumulative frequency is always going to equal the total of your frequencies. So you have that as a check. And that's how you go about finding cumulative frequencies.